Okay, welcome to Chapter 7. Chapter 7 is dealing with numbers, mainly percents, decimals, and fractions, and how they're interchangeable, or how you can go from one to the other and it doesn't change anything. Percent change in 7.1 is looking at how big of a change have we made to a number with regards to how small the number is. And this is really important. For example, let's think about weight. Okay, if you talk about, say, gaining 20 kilograms, that could be a lot or a little depending on how much the original object weighs. For example, take me. There's a picture of me. I weigh about 80 kilograms, and so if you were to add, say, 20 kilograms, I would get much bigger, okay? Because that's about a quarter of my body weight. So this is me, much bigger. When in reality, I'd just be heavier, wider, and all around, things would be worse. So that's because it's a large chunk of my original body weight. I'm adding about a quarter of my body weight. Now, if we took something really heavy, like this aircraft carrier, for example, that holds, tens of jets, helicopters, people, machines, weapons, you name it, right? People live there. If you take this and you were to add 20 kilograms, that would make not even a noticeable difference on any level. Okay, that's like bringing a small child on board. The boat would sink, a fraction of a millimeter deeper into the water, but a very, very small difference. And that's because of what a chunk of the original amount 20 kilograms is. In terms of my body weight, about 80 kilograms, 20 is a huge percent. Okay, whereas in terms of the weight of that boat, 20 kilograms is a very, very, very small amount. So the actual change is a lot in comparison with my body, but a very small amount in comparison with the boat. Okay? Another way to think about this is as a giant pie, right? And it's about, okay, I don't care what number I gained or what number I lost, right? Because I need something to compare that number to. And so the real question is, how big of a slice of this did we take out? Did we take out a tiny little slice, right? Or much smaller than this slice in the case of the boat and the weight, okay? Or did we take out some huge chunk of this, okay? Did we take out this whole blue area? Or did we just take out a little red sliver? Okay, and that's what this whole section's about, is regardless of whether it's dollars or weight or time or speed, whatever it is, we're saying, was the change a big change? Like, was it 50% of the original? Or was it a small change? Was it like 4% of the original? Right? Because if I tell you, this thing is $100 off or 100 francs off, you'd be like, wow, what a great deal. And I'm like, but it's a car that costs, 150,000 francs. You're like, 100 francs off really isn't that big of a deal. Whereas if I tell you it's it's a shoe that usually costs 101 francs, and now it's 100 francs off, it costs 1 franc, you'd be like, oh my God, that's an amazing deal. I'm gonna buy 100 of those, right? At least you need to buy 2 shoes. Okay, so let's start with the problem. Okay, here's as simple as the problem gets. They give you an original number and they give you a new number, and they ask you how much of it changed. Okay, well, this is very simple. We've got this one formula, which is the actual change. This could be dollars, this could be minutes, this could be a weight, a height, a length, anything, over, and then the original. Okay, and this gives us the chunk out of the original that was the fraction of the original. And to turn it into a percent, we just times it by 100. Okay, so in this case, we would say the actual change, the difference was 54 minus 50. Okay, so it was a change of 4 over the original. This is the most important part. You need to know which is the original. An all too common mistake is people just taking the smallest number or taking a random number out of the two that they just grab a number. You need to be very certain. Okay, the original is 50. All right, and then times 100. And so we get 4 divided by 50 times 100. And when you punch that into your calculator, you get 8. And that means 8%. That's how much the first price increased by. It used to be $50 and now it's 54, maybe with tax, maybe with tip, and so it's 8% added on. The final thing you need to include here, other than the original question, showing your work and the answer, is you just need to write whether this was an increase or a decrease, and you can do that with an arrow. You could say this went up 8%, okay? Or you could write out the word increase, and that is part of your answer. That's about half your answer, okay? So the total change was it went up 8%, or up about 1/12 of its original size. Okay, now this could also be a decrease. Okay, and this is where people maybe get a little more confused. And so we start with our difference, or our actual change, over the original times 100, okay, which in this case is 800 minus 600. Doesn't matter whether it's positive or negative. You can just subtract the bigger number minus the smaller, and then take the original price. Make sure you know which one's the original. Okay, a lot of people write 600 on the bottom here because it's the smaller number. I don't know where that habit comes from. Okay, but make sure you know the original is 800. Alright, times 100. That gives us 200 over 800 times 100. Punching that into our calculator, and yes, you're allowed to use a calculator, is 0.25 times 100, okay, or 25%. And finally, at the end, you say whether it went down or up. This one went from 800 down to 600, so this was a decrease of 25%. Okay, and you could write the word decrease. Okay, and they could give you this type of problem in terms of a word problem also. Okay, here's an example. The moral of the story, after reading through it, is an iron rod starts as 200 and becomes 200 point, that's a decimal, 5. I know they write their decimals pretty high in this book, so don't be confused by that. Alright, and so we say, okay, well, let's go to our formula. We got the difference over the original times 100. Okay, so we've got, I'll do it in blue here, we've got our 200.5 minus 200 over 200 times 100, okay, or 0.5 over 200 times 100. And now don't get confused here. When you plug this in, you are going to get 0.25%, not 25%. And looking back at your problem, that makes sense. 25% would be a quarter of 200, or about 50 would be a big number, right? So 0.25% means a tiny amount changed, okay? And so your answer would be that this went up from its original 200, and we use the correct original here. It went up 0.25%, okay? And people get confused by a couple of things there. They see 0.25% and automatically want to switch it to 25%, but you should be able to look back and just say, oh, ballpark, yeah, that looks right. It changed by less than 1%, from 20 to 20.5, okay? saw it as you got 25% as the answer, you look back and go, whoa, 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 it did not change by a quarter of its total. It just changed a tiny bit, so you know it was wrong. Okay, and then in exercise 4, they give you trickier problems where now they're not asking that same question. They're not saying it went from this weight to this weight, what is the percent change? Now they're giving you the percent change and saying you find the second weight, you find. So in this case, they give you the original lengths of a rectangle or of a square, and then they say one side went up by 20% and one side went down by 20%. And these are dealing with relatively easy numbers, but it's now doing that reverse, right? And so for this, you're going to have to understand percents and decimals and fractions a little better. So what I'm going to do is stop here, and I'm going to make a separate video about how to answer these word problems. Okay, so enjoy this, and I'll post a second video.